Good morning, geometry students. Welcome to class today. Hope you guys are doing well. Hope you're ready to learn some math today. Hope you had a really nice Christmas break. I commented to my wife, this has been one of the most relaxing breaks that we've had in a long time, so I hope you guys also feel the same way. Um, Couple announcements here. There will be a quiz this Friday, and I'll go over that in a little more detail on Thursday. Number two, make sure that you stay on top of your homework. You guys did a really good job last semester, and I want to remind you that I'm going to be checking my box. I did a really good job last semester. I'm going to do an even better job this semester on checking my box regularly and emailing your parents if you're not turning your homework in. So please get that. Um, please stay on top of that. Let's keep the Harwood family in our prayers, guys, and don't just say that, but really mean that as you think of them walking down the hallway or whenever you think of them. Just pause. You don't have to close your eyes when you pray every time that you pray. Just ask the Lord to strengthen them, to help them, and encourage them in this tough time. Okay, and then also due to this situation, there will not be class tomorrow. So when I made my lesson plans, I did not know that, but because of that, you will have, of course, an extra day to get your homework done. And I hope that you'll come to the funeral tomorrow and support the family, but you'll still have an extra day there to get your homework done. So that's basically it on the announcements. Again, I hope you guys had a good break. It was really good to see you guys during the exam, and hope you guys are doing well. Let's go ahead and get started. Let me quickly grab a drink here. And let's go ahead and get started. Grab your notes, pencils, books, and everything that you need. We're going to start off today looking at Chapter 7. Now, you do not need to write this down, but Chapter 7 is all about similar polygons, predominantly similar triangles. And so we're going to be looking a lot at that topic. Go ahead and write down ratios and proportions, lesson 7.1. Ratios and proportions, lesson 7.1. The date today, if you want to write this down, is January 7th. Of course, it sounds a little weird, but 2014. Okay? Ratios and proportions, lesson 7.1, January 7th. Please write that in your notes. Also, write this in your notes. I will quiz you or test you on this, so please write this down. A ratio is a comparison of two numbers. Okay? A ratio is simply a comparison of two numbers, and you don't have to write all of this down, but it could be a quantity of something. It could be a measurement. It could be a lot of things, but a ratio is a comparison of two numbers. For example, let's think real quick. We have Azu, Jasa, Martin, Jake in class. And then Haley also. We're going to go ahead and include Haley. Now, if I said write the ratio of males to females, well, I would put, let's see here, we have Jake and Martin are my males, so I have two males, and my females, Azu, Jasa, and Haley, would be 3. So the ratio of males to females would be 2 to 3. Another way to write that would be 2:3. And that's a ratio. That's all that a ratio is, a comparison of two numbers. We write a ratio with the word 2, or you can write a ratio with a colon, or you could also write a ratio as a fraction, 2/3. How did I know what number went up top? Well, males came first, females came second, so the 2 came up top, the 2 went up top, the 3 in the bottom. Now what if I said write the ratio of females to males? Well, that would be 3 to 2. Okay? What if I said what's the ratio of males to the total population? Well, how many males are there? 2. And what's the total population? 5. 5 people in the room. Okay? What if I said write the ratio of females to the total population? Well, there's 3 females, and the total population would be 5. Do you see what I'm saying? Those are all ratios. They're a comparison of 2 numbers. Could be a quantity, a population, a measurement. But it's a comparison of 2 numbers, and that's what a ratio is. Now let's continue on. Write this in your notes. Ratios are usually written in their simplest form, and they can be reduced like a fraction can be reduced. Now remember, I go fast. I'm going to keep right on going. Okay, if you have to pause the video, then pause the video. Ratios are usually written in their simplest form. They can be reduced like a fraction. So if I gave the ratio 60 centimeters to 200 centimeters, you would want to reduce this, okay? 20 goes into both of those numbers, just like a fraction. So be sure and write ratios in their simplest form, okay? So the ratio is 60 to 200, and 20 goes into 60 how many times? 3 times. And 20 goes into 200 how many times? 10. There we go. So you just reduced this ratio, okay? So again, ratios are usually written in their simplest form. You can reduce them just like a fraction, okay? So please write this down. All right, here's another one. Now be careful on this one, please. Be careful on this one. We have feet and we have inches. You cannot reduce this one. See, a lot of students would look at these two and say, oh, I can reduce it. 3 goes into both of these numbers. Yeah, but be careful, guys. You have feet and inches. So you have to either make them both inches, and of course 3 feet would be 36 inches. Or you have to make them both become feet. And over here we would have 3 feet and 18 inches is 1.5 feet. Do you see what I'm saying? So whenever you write a ratio, make sure your units are the same. They should both be inches or both feet, or whatever the situation might be. It could be gallons, quarts, centimeters, meters, whatever, okay? So do not reduce a ratio like this. You first want to write it so that you have the same measurement, okay, or the same unit of measure. Now that we've rewritten this into inches, both of them are in inches, let's go ahead and reduce this. What number goes into 18 and 36? Well, 18 does. 18 goes into 36 2 times, and 18 goes into 18 1. So there, you reduced the ratio, okay? There we go. And so your ratio there is 2 to 1, okay? Now, if we come over here and try to reduce this, there's really no number that we know of that goes into 3 and 1.5, okay? So we can't reduce that. But again, ratios are usually written in their simplest form. They can be reduced like a fraction can be reduced. So please understand that, and please be able to do that. All right, let's continue on. Now, go ahead and copy this problem in your notes. I'm going to talk for a second and then get into it. You might need to pause the video if I go too fast here. But the ratio of segment AB to segment BC is 4 to 1. So there's the ratio. The length of AC is 30. Find the length of AB and BC. All right. Now I'm going to move this down to get a little room to work here. There we go. Go ahead and copy this in your notes. I'm going to keep moving, and let's see how we can do this. Now, first of all, we notice the ratio of AB to BC is 4 to 1. So that means for every 4 parts here, I have 1 part here. Now, you don't necessarily need to write that. I'm just showing you what it means, okay? If the ratio is 4 to 1, here's how we're going to solve this problem. By the way, first of all, go ahead and make a note here that the length from A all the way to C is 30. Remember, that was given to you, okay? The length of AC is 30. Now, the ratio of AB to BC is 4 to 1. So I'm going to put a little 4 right here for AB and a little 1 right here for BC. Now, I don't know the length of of all of these little segments. Remember these little segments I just wrote up here a second ago? Whenever it says the ratio is 4 to 1, that means it's 4 parts to 1 part. But if I called all of these little parts x, do you see what I'm saying? I don't know what they are, but let's say I called all of those little parts x, then what I could put is 4x for this whole segment right here, and I could put 1x for this whole segment here. Now some of you might have understood what I just said, some of you might not have, but you can all at least memorize what to do here. It's not that hard. If the ratio is 4 to 1, then I simply put 4x for this segment and 1x for this segment. There we go. That's not too hard. Now, all that I have to simply do is take my one segment, 4x, and add to it my other segment, which is 1x. And when I add these two little segments together, they should equal what? 30. There we go. Because the length of the whole segment is 30. So 4x plus 1x would be 5x. Now divide both sides by 5, and x equals 6. Now we're not done. They said find the length of AB and BC. We just found x. Now AB is 4x, right? AB is 4x. So if I put a 6 right here, 4 times x, or 4 times 6, is 24. So now I know the whole length of AB is 24. And now over here I have 1 times x, or 1 times 6. 1 times 6 is 6. So the length of AB is 24, the length of BC is 6, and by the way, if you add them together you get 30 like you should. So there we go. The length of AB is 24 and the length of BC is 6. Let's try another one and get you some more practice on these. Okay, go ahead and copy this in your notes. The ratio of segment EF to segment FG is 2 to 1. I'll move it down here. The length of EG is 24. Find the length of EF and FG. So just like the last problem. Well, let's see. The ratio of segment EF to FG is 2 to 1. So I'm going to put a 2 and a 1. The ratio of EF to FG is 2 to 1. Then you can put an X with each one. There we go. And now the whole length of this entire segment is 24. So I know from E all the way to G, the entire length is 24. So here's what I'm going to do. I know if I take the length of my one segment EF, which is 2x, and if I add to it the length of my other segment here, which is 1x, I will then get 24. If I add the two segments together, I will get 24. Now 2x plus 1x is 3x. And if you divide both sides by 3, x equals 8. That's not your answer, okay? But now we know what x is. So the measurement of EF is 2x, or 2 times x. And so where the x is, I'm going to put an 8. So 2 times x, or 2 times 8. So I know EF has a length of 16. Now for x right here, 1 times x, or 1 times 8. 1 times 8 would be 8. So there we go. The measurement of EF is 16. The measurement of FG is 8. And by the way, if you add those together, you get 24 like you're supposed to. But there you go. You found the length of EF and FG. Okay? So we're using ratios. Pretty cool. You had no idea how long each segment was, but yet by using ratios, you could figure that out. Okay? Let me go on to the next page and get a quick drink here. You can copy that down if you want to. Okay, let's apply ratios now to this problem. Okay, the perimeter of this rectangle is 80. The perimeter, the ratio of the length to the width is 7 to 3. The ratio of the length to the width is 7 to 3. Find the measurement of the length and the width. Now, let's be careful here, okay? First of all, off to the side, I'm going to write perimeter equals 80. Now remember what that means? That means if if I add this side plus this side plus this side plus this side, I'll get 80. If I add all four sides together, I'll get 80. Now, the ratio is 7 to 3. Now, remember what that means. That means I can put a 7 right here with the length, the longer side, and a 3 with the smaller side. And don't forget what that means, by the way. It just simply means that we're dividing this segment up into 3 parts and this segment here into 7 parts. Okay? And so I'm just simply saying for every 7 parts I have here, I'll have 3 parts here. Remember, if we called all of these little segments x, if I did that, then that means I could put 7x and 3x. And that's what I'm going to do. Does everybody see where the 7 came from and the 3? The ratio of the length to the width is 7 to 3. That means the 7 goes with the length and the 3 goes with the width. 7 to 3. Okay? So, where the length is, I put a 7. Where the width is, I put a 3. And I put an x with each one. Now, think about it. We have a rectangle, right? So, if we have a rectangle, if this side here is 7x, then this side down here is also called what? 7x. They're congruent. And if this side here is called 3x, what do we call this side over here? 3x. Now, I know if I add all 4 sides together, I would get the perimeter, and the perimeter is 80. So if I take 7x plus 3x plus 7x plus 3x, if I add all 4 sides together, I will get what? 80. And now I can quickly solve for x. 7 plus 3 plus 7 plus 3 is 20x. And then divide both sides by 20, and x equals 4. That's not my final answer, but I'm going to come up here and put length equals and width equals. Now x equals 4, so the length is 7 times x, or 7 times 4. So the length is going to be 28. Now the width, is going to be 3x, or 3 times x, or 3 times 4, and so your width would be 12. And by the way, if you were to reduce these two numbers like you would a fraction, you would get 7/3, or 7 to 3. Okay, so there you go. You found the length and you found the width of a rectangle when all that you knew was the perimeter of the entire rectangle, and you knew the ratio of the 2 sides was 7 to 3. Pretty cool, okay? So that's what we're doing today. We're actually building up to using proportions and ratios for this whole chapter. So we're kind of reviewing a little bit, okay? All right, let's continue on. Now, we've been talking a lot about what? Ratios, ratios, ratios. Well, now we're going to take a look at the word proportion. So please write this in your notes. I'm going to grab a drink here. A proportion is when you have 2 or more ratios set equal to each other. Okay? So a ratio is when you have one fraction or one comparison of 2 numbers, like 3 to 6 or something like that. Okay? But when you have 2 of these ratios set together, 2 or more, then you have a proportion. So hopefully you've written this down by now. You do need to know this for your upcoming tests and quizzes. And now watch this, please, students. Please watch this carefully. When 2 or more ratios are set equal to each other, you have a proportion. Now watch. If I said 1/2 equals 4/8, that would be a proportion because I have a ratio here and a ratio here set equal to each other. And by the way, that's a true statement. If you were to reduce 4/8, you would get 1/2. I could write something like this. The ratio 2 to 3 equals the ratio 16 to 24. And now that's a proportion. I have a proportion. How do I know that? Because I have a ratio and a ratio set equal to each other. Over here I have a ratio and a ratio set equal to each other. That's all that a proportion is. It's two or more ratios set equal to each other. And you say, what do you mean by two or more, Mr. Well, you could have this. You could have 1/2 equals 3/6 equals 4/8. Okay? Now all of these fractions equal 1/2 if you were to reduce them. So I have a ratio and a ratio and a ratio all set equal. This would be a proportion right here. Okay? Now I want to show you something else that's really interesting. You should know this from middle school, but whenever two ratios are set equal, you can multiply these two numbers here and multiply these two numbers here, and they will always come out to be the same. Isn't that cool? As long as you have, of course, as long as you truly have two equal ratios, if they're truly equal and they're set equal to each other, you can do what we call cross multiply like this, and you will get the same number. Let's try it over here. The ratio is 2 to 3, or 2/3, equals 16 to 24. Now, I'm going to cross multiply. So I'm going to multiply 3 times 16. That gives me 48. And I'm going to multiply 2 times 24. That gives me 48. So there we go. So we're going to use that principle in just a second to solve some problems, okay? But let's review quickly. What is a proportion? When you have two or more ratios set equal to each other. Number two, whenever you have a proportion, you can cross multiply and you will get out equivalent statements. These two sides should be equal, okay? So now let's take a look at some problems. Please copy this in your notes. What if I said the ratio of 3 to x equals 6 to 18? I want you to find x. Now, a lot of you might be able to do this in your head, but be careful, because I'm going to give you some like this one and this one that you can't do in your head, okay? So be careful. But a lot of you could look at this and say, oh, this is easy. I noticed that the 3 went to a 6. That means I multiplied by a 2. So what number would I have to put here that I would multiply by 2 to get 18? Oh, it's got to be 9, because 3 times 2 is 6. And 9 times 2 is 18. And if you did it that way, you're correct. But the only problem is, what are you going to do when we get to problems like this one here, and 5 doesn't go into 21 evenly? Okay, so be careful about doing these in your head. I don't mind that as long as you know how to do it the other way also, okay? So let's go ahead and let's solve this for x, okay, using a method called using cross multiplying. Now, we have two ratios that are equal, okay? Thus we have a what? What is this thing called? It's called a proportion. Okay, so I have a proportion. I'm going to solve for x. So I'm going to cross multiply like I just showed you in the last page. X times 6 would be 6x, and 3 times 18 would be 54. Got it? And then, of course, what I tell you can do when you cross multiply, you set the two products equal to each other. Okay? Let that sink in. See if you have any questions. Shouldn't be too difficult. And now I have an equation I can solve for x. So I'm going to divide both sides by 6, and 54 divided by 6 would be 9. So there you go. You solved for x. 9. These aren't that hard, students, okay? All right, let's try this one here. All right, now I've got a proportion here. How do I know that I have a proportion? Because I have two fractions or two ratios set equal to each other. Okay, and a ratio is a fraction. They're the exact same thing. Now, I'm solving for x. I'm going to cross multiply. It doesn't matter which two numbers you multiply first. It's not a big deal. 3 times 21 would be 63. 5 times x is going to be 5x. And then set these two equal. Now we simply divide both sides by 5. So if I divide this side by 5 and divide this side by 5, these cancel, leaving me with x. And now you can use a decimal if you would like to. That's fine. 5 would go into 63, 12.6. You can use a calculator, 63 divided by 5. Or you could also put, if you wanted to, you could put 12 and 3/5. I would accept either one of those two answers. But do you see how you did not get a whole number for your answer? Let me get a quick drink here. Do you see how you did not get a whole number? And that's why it's important to know how to use this method right here where you cross multiply. Okay, so there we go. The answer is 12.6 or 12 and 3/5. Let's take a look at one more. Okay, let's solve for y. And this is going to be a little more difficult, so please take some really good notes. Copy this down. By the way, this is our last problem, and we'll get to the homework, okay? All right, now let's go ahead and cross multiply. All right, here we go. We're solving for y. We have a proportion here. So now when you multiply, it's 3 times y. Now don't miss this. And it's also 3 times 2. This is 2 terms right here. Because of the plus sign, I have 2 terms. So when you multiply by 3, you do multiply both of these terms by 3. So 3 times y is 3y. And 3 times 2 is a positive 6. There we go. And now we multiply this way. 5 times 6 is 30. So look at that. Now we have just a good, easy equation we can solve, okay? We want to get y by itself, so the first thing I'm going to do is bring the 6 over and make it a negative 6. So this is gone. So now I'm left with 3y equals 24. And then divide both sides by 3, and y equals 8. So there we go, we solved for y. So that's it for today. We've looked at proportions and we've looked at ratios, okay? Make sure you understand those, do really well on your homework. Do not skimp or go light on your homework. Do your homework and do it well. Now I want to give a little reminder to you. When you go to look at the video, Geometry 7.1 homework, this video, listen to me, everybody listening? Listen, this video was made when? Last year. So ignore everything that the video says about tests coming up, quizzes coming up, when your homework is due, what day it's due. Just ignore all of that, okay? I've already told you your homework is due Thursday because there's no school tomorrow. You have a quiz on Friday. The only thing you're listening to when you listen to this video is how to work out the problems. And by the way, I have a fear that a lot of you sit down with your paper and pencil and just turn the video on and watch it and copy it. You understand that's your business, but you're hurting yourself. The idea behind the geometry homework video is for you to do the homework, and then if you get stuck on a problem, watch it, okay? You can always check your answers in the back of the book, and you can check your evens by kind of fast forwarding the video and looking at the answers. Now, if you do your homework with the video on and kind of watch, that's fine. Maybe you do a problem and then play the video. That's up to you. But make sure you're really doing the homework, okay? And not just copying it, okay? I hope you guys have a good day, and I look forward to talking to you guys tomorrow.